I'm Greta, CEO of Acerta. Let's talk about machine learning in manufacturing. A machine learning model is created by running training data through a number of different methods or algorithms so that they learn to handle new, unseen data. After being trained and tuned, the models are tested and the best performing ones can be used in your application. We can break down how to develop machine learning solutions into 5 steps. Step 1. Identify your problem, data inputs, and expected outputs. Before you can start to build a model, you first need to determine what problem or use case you're trying to solve and what data you have available for it. Are you trying to determine if newly manufactured motors have a defect? Do you want to understand the cause of your defects? The problem you are trying to solve will impact how you treat your data and which machine learning models you can use. Once you clearly define the problem, you need to assess the data you have available. Does your data contain the outputs you are looking to detect or predict? If you're looking for defective parts, does the data contain labels or the defects? Also consider the relationships between inputs and outputs. We have to assume that there is a relationship between the two and that we have sufficient available data to learn these relationships. Machine learning algorithms rely on patterns being present in the data. If the relationships are not present, the models won't be able to determine the outputs themselves. Lastly, clearly define what success looks like. Step 2. Transform your data so that it can be used by a machine learning model. Before we can apply our machine learning model to our data set, we have to clean up the data. So we would remove all duplicate, null, or missing value. We would map continuous and discrete features, standardize, normalize, and identify redundancies in the data set. Step 3. Divide your data into training and test set. The denser the data set, meaning it contains valuable information in relationships and is generally larger, the better the trained models will perform. On the other hand, if the dataset contains limited information and no valuable relationships, then the trained models will not be effective no matter how much of the data you have. Once we get a clean dataset, we randomly divide the data into 2 parts, training set and test set. We teach the model with the training set and then evaluate its performance on the test set. So make sure there is no data leakage between these sets. None of the test data should be found in your training set. In models that are trying to classify an object, like determining whether manufactured part is defective or not, we divide the data into train and test sets randomly, but we preserve the proportion of defective and non-defective parts in each set. If we're trying to predict the future, like when a tool is going to wear out, you have to divide the data carefully as the time sequence is crucial. Step 4. Pick a machine learning algorithm that fits your problem. Depending on the problem you're trying to solve, a different set of machine learning algorithms can be leveraged. If we go back to our defective parts example, the problem we're trying to solve is to automatically classify parts as either defective or not. For this, you would choose a classification model, such as k-nearest neighbors, where data points are grouped by proximity. To predict tool wear, on the other hand, we need a regression model, such as a linear regression or a variety of neural networks. Step 5. Find the model with the best performance. Once you know what model you can use, you need to tune their performance to meet your desired outcomes. Tuning involves adjusting the learning parameters and the model architecture parameters to achieve a desired performance. Let's again look at our defective parts example. For a binary classification example like this, to analyze performance and the trade-off between false positive and true negative rates, we can use AUC, or area under the ROC curve. A number of different models can be tuned and their performance is compared using this metric before a final configured model is chosen for deployment. This 5-step overview is just the tip of the iceberg when it comes to machine learning. We'll be covering many more areas of this powerful tool for engineers and data scientists. Thanks for watching.